happen to be in need of a keynote speaker for this SOS. And I wanted to have an industry perspective on this, and we have an industry panel. I think that's really important. So Roger has been lots of places. He's going to tell his own story, but he brings a combination of perspectives, including that of right now he's with a startup, which I think is really interesting and useful for our space, because we need to be thinking out of the box to treat the problems that we've got. So without further ado, and anticipating a self-introduction, I'll say Roger Hill. Thanks, Roger.
Thanks, David. Really appreciate the opportunity to be here this morning and maybe have a different type of a discussion from the usual community that you have in terms of academia research. So I come from the industrial control system space for about 25 years. Before going out in the startup world, I was with Siemens for about 16 years. In that time, I worked with virtually every aspect of industrial control systems, from PLCs to motion controllers and drive systems, and spent about 6 years in a systems engineering function for the SCADA systems. And then we had a little thing called Stuxnet happen. And so I started up the managed security services business for Siemens globally. And did that for about 2.5 years. At the same time, I was tech due diligence for everything cyber with the Siemens Ventures, which really translates into I talk to all the Israeli startups. And some of them had some good ideas, and others I just felt like I could do that. So finally, after a few years of frustration and seeing some needs in the industry sector, I really wanted to address it. And so I started talking to my wife about what would you think if I left Siemens, my guaranteed job for life, and go do a startup. And she supported me, so I'm pretty sure it's not a midlife crisis. I'm having a lot of fun. I haven't had this much fun in years, so it's really good. So anyway, go ahead. So I'm with Veracity Security Intelligence. They are a startup that's been around for about 18 months. I've been with them for about a year now, or just over a year actually. Before I came on board, they started off with anomaly detection. And it's kind of a flooded space in the startup community for anomaly detection. So they pivoted away from that, and they started working on this code stack, a real tight code stack where they could actually integrate with embedded devices such as PLCs. And then I kindly told them why that would never work. But I told them I have something that will work. So we kept the name, but that's about it. So we pivoted the company about a year ago. And I'm not, rule number one when you're presenting, you need to know your audience, right? So I don't know necessarily the background. So I thought I'd go ahead and start the way I found to be very, very effective when talking about industrial control systems. And that's by using the Purdue model. So anytime I'm engaged with IT and OT, operations technology, I found that just putting it into these logical blocks really helps the conversation, because then everyone has this common language. Okay, this layer 1 device, layer 2 device. So when looking at the Purdue model, safety zone, typically we treat that as its own zone. Safety instrument systems, safety PLCs, safety I/O. Then we go into our field device network. Probably 90% of those networks today are still RS-485. We're seeing a lot more different Ethernet-based deterministic communications in this area now. Then we get into our basic control, and this is really made up of the things that are controlling the things. These are the programmable logic controllers, PLCs. Very modular. They have I/O that's talking to the real-world devices. Process automation controllers and motion controllers. And then once we get into our area supervisory control, this is your human-machine interface, the HMIs, SCADA systems, and typically you're looking at the best practices are to have a DMZ, and that's literally your man in the middle from getting that shop floor data up to the higher level systems. The type of assets you see at that DMZ level are, historian web interfaces, SCADA web servers, and things like that. And then you get into the ERP. Like I said, this is just a good building block for having a good dialogue. Basic rule is no layer should talk more than one layer up, one layer down. So the industrial space, we started really focusing on oil and gas and chemical. They had started with energy sector. I pulled back because I felt like it was a lot of dinosaurs that moved really, really slow. And I wasn't really thrilled to get into the regulated space because it's just too much of a focus on compliance, not security. So that, from my previous work, I had found chemical and oil and gas to be a little more early adopters. So that's why we're focusing there. But being opportunistic as a startup, I find that we're being pulled back into energy again. So, but ultimately, when you look at industrial control systems, it's a huge market, huge market. Everything from building automation, a lot of silicon manufacturing, automotive is huge. That's where automation really got its start. But there's some common themes in all of these markets. They all have long life cycles, and it really depends on what layer you're talking about too. The vendors will spread a lot of FUD about the long life cycles. But the reality is that I think you can look at it from a bottoms up. It comes down to copper wire on the PLC. That's the last thing to get replaced. And it's not just the copper. It's the length of time it takes to actually replace one of these devices. It has nothing to do with the cost. It's the engineering effort. It's the procurement cycle. It's the coding. It's the factory acceptance test, commissioning. It's a good 2-year project. There's a lot of the protocols you will see across all of the sectors. For example, Modbus TCP, that's an industrial protocol that you'll see virtually everywhere. You'll have some that are more dependent. So DMP3 is really predominantly in the power sector, but you do see some in the water, wastewater. Goose, really in the power. But then you get into a lot of the vendor-specific industrial protocols, and since you have a lot of common components in those industry sectors, you'll see a lot of the use of these protocols within those sectors. Industrial communication is really about deterministic communication. It's just something happening in a very regular cycle. It's not necessarily all about real time, but it's more important to have deterministic communication. So there's a lot of cross vendors and devices across this area. So what we did is looking at it is trying to define what's the problem statement that we want to address so that we can address it from a technology gap, but also from a business perspective. First and foremost, I have to say it's absolutely visibility. In industrial networks, pretty much every sector, maybe not as much power utility because of some of the NERC SIP for the critical systems, but there is a complete lack of visibility. There's a couple of things that lead into this. Number one is, you see a lot of these different IT-centric startups that are trying to address this space right now, and they're all stating, oh, let me set off that main switch off that span port in a very passive manner. My algorithm is better because of X, Y, Z. I'll detect everything bad happening. The reality is, off that main switch, or think of that DMZ, that north-south interface, that probably represents 5% of your communication. And there's no control going across that. The control is happening way down below. Right? So if you think about the PLCs, the most critical devices, the things that are actually controlling the things, are actually plugged into just a DIN rail mounted 4 or 6 port dumb switch. And there's no visibility. There's no span port capability. And I'm not a huge fan of span anyway, mainly due to you can't necessarily trust the timing of the frames, and it's the lowest priority. Before going in this area, I was a much bigger fan of taps. That presents its own nightmare in terms of infrastructure. Lots of cabling, lots of sensors. Where do you place them? So we have some problems in this space. So one common theme I get from any of the IT folks that just inherited their OT space for a manufacturing site or something else is, okay, what did I just inherit? So then they start asking, well, I don't know. You can't even do some of the common scanning techniques that we're used to within IT systems. And it has to do with the way they're actually subnetting, some of these broadcast domains. They're just doing with some subnetting techniques, sometimes VLANs. It's really nice. Another avenue that is a real problem in the space right now is the complexity. My personal view of the complexity is it's tied to a culture. That's how these engineering projects are actually taking place with integrators and solution partners. You typically on a project, you'll have several different integrators involved. They're dealing with the requirements of the application or the process, but no security requirements. These long life cycles, which depending on the layer, you can look at anywhere from 12 to 20 years. And in my 25 years, I probably have only seen 3 greenfield sites. Greenfield is just such a small percentage. And the other aspect is, I'd say 95% of the time when you're looking at some type of a migration project, it's for one part of the facility. It's one aspect of the system, not the entire system. So what you end up with are very mixed mode systems from Windows NT 4 on one part of your network and 2012 server on the other. And then trying to secure that on the same network presents its own challenges. And we really have a lack of subject matter experts, not just cybersecurity, but the type of folks that can understand the process so that when you walk into a facility, and I know instantly if I palm that SCADA server, what I can actually affect on that physical process. That's the type of knowledge we need to understand the cyber physical systems. And finally, the risk. Risk is really dependent on some of these other. There's no way to determine risk until you know what you have, right? But it's also about perspectives. So if you look at the automation vendors, the Siemens and Rockwells, the Honeywells of the world, they are selling at the site level or the engineering level, not from the top down, from the CISO, right? So when you're talking to the operational folks, they are not convinced that China and Russia are out to get them, especially outside of the power sector. What they're most concerned with is that insider, and that's not even the malicious, it's misconfiguration, misuse is the largest cause of downtime. Downtime is money. Now, if you go to the top-down approach, it's APTs, emerging threats, it's all the FUD that we see everywhere. So it's really about different perspectives. So there's some industrial networking challenges today too. First of all, if you look at the network infrastructure vendors, about the only vendor recognized from an IT perspective is Cisco, and they're not even a large player, in the industrial space. They're climbing. They're probably number 5 or something like that. So you have a lot of mixed systems, and typically most systems will actually be mixed vendors as well. They're all proprietary, closed systems, no centralized configuration, and typically with most of these industrial switches, it's just simply a web interface configuration on that specific switch. So another major challenge in the network side is really the network operational requirements are really at odds with some of the cybersecurity controls and policies that we need to deploy. There's actually limited security controls and capabilities today within the industrial market. Most typically, you'll see some, basic ACLs and, enabling and disabling ports. from my personal experience, I found virtually no auditing of the configurations once it's deployed. And in my 20 plus years of visiting different sites, I've rarely found a network that didn't have some type of problem already. And the issue is they don't know about it. They have no mechanism to know about the health and status of their network. Another complexity here is really a lot of competing industrial redundant protocols, ring topologies, competing against vendors, and it really is a truly distributed network. So when we look at the problem statement, what we did is we had some overarching goals that we also wanted to accomplish.
Do you want questions now?
Oh, anytime.
I'm just curious about
Very
the
frequent.
configuration problem. Is that because it's hard to configure these things, or is this lack of best practice, or should it be easier?
I think all. So it's really across the board, and it might vary a little bit according to sector, but I've been involved in many systems where the same integrator that won the bid for the PLC code, and maybe they're doing the SCADA system, yeah, sure, we can design the network. So anyone that can do Visio, they're a network architect then. And well, that's just the way it is. And it's really quite a mess. That's probably not the case on the Cisco Industrial Ethernet as much, but I visited that firsthand with the Siemens Scalence and some of the deployments there and some of the others.
So I presume there's some degree of standardization in that community because things have to interoperate.
Between more on the protocol side. So if I'm running HSR, for example, yes, so there's good documentation, there's training. If you look at the field bus side, like on Profinet, there's different certifications that you can get. I am Profinet certified. But the problem is large enough that Siemens is looking at this and, hey, we can make money on doing a certification, network certification. But how do you do this? Because their goal is to move away from a classical project engineering into more of a subscription services. So the real ideal scenario is there a way you could do this remotely by monitoring? Well, chicken and egg, because now we're back to that system where we can't get any data or any information. So it's really a cultural issue. It's how these projects are employed and the integrators and solution partners that are doing them. I think that's the biggest challenge. But there are a lot of good best practices and network designs for industrial, but it's across vendor. Even with a single vendor, you're going to see multiple families depending on the protocol.
Is there any structure in which people do this kind of certification to see if the best practices are being followed, or is that?
Yeah, so let me give you another example. So Siemens is doing that for Profinet, and I think Rockwell has a service arm that's doing it for their network architectures and their converged plant-wide Ethernet partnership with Cisco and for their SIP protocol. But let me give you an example of automotive. Typically, if you're for some large customers, like the big three, part of their requirements will actually be their own network design requirements. So that end customer is actually pushing it. So it depends. It's the classic answer in the space. Did that answer your question, though? Or,
yeah.
So the IT, I think everyone's heard about the IT-OT battle. It's very real. This is why Rockwell and Siemens create PCs, computers, that look like a PLC and sit on a PLC rack. Is there a need for that? No, not really, but it's mainly for the OT folks to say, no, this isn't a PC, this is industrial, see, it's rugged. It's a classic battle. So as we were engaging on the security space and doing assessments at Siemens, we're trying to bring those worlds together now. And it's a challenge. It's a challenge. So one of our goals here is we need a mechanism, a way to bring these two worlds together. Let me give you one example. When we're doing assessments, going through and doing the as-is network topologies and data flow diagrams and so forth, and we get to that stage where we're designing proposed network segmentation and security zones and everything. There's so many stakeholders involved from the customer side, from the OT, IT, that this review process of, as a consulting firm, and going back and forth with all the stakeholders and the customer, a 4-month minimum process, and just manually intensive. So what we wanted to do is have a system that brings absolute simplicity in terms of visualization, literally to the point where you can drag and drop one asset from one zone to the next, and instantly you're tasked with, what is this configuration change? You capture the old state, the new state, proposed change, everyone's notified in that peer review team in near real time, they can log in and make a change. So that's the type of simplicity that can really bring those worlds together. The network versus cybersecurity, this is another goal that we had, was we wanted to address this space in one unified platform that you don't have two separate tasks, but they're actually highly related in terms of network configuration and orchestration, and the cybersecurity policy or some of the whitelisting that we're doing in terms of policy. So there's a lot of good defense in depth best practices and standards and guidelines out there for industrial systems today. There really are. The one thing that when I look at that whole security onion defense in depth approach, though, it tends to feel almost like the waterfall development process to me, where you'll spend a good couple of years just working on that requirement spec, and you're trying to imagine every scenario. Instead, what if we looked at this in a slightly different perspective in designing our segmentation and security zones, and start thinking in terms of aligning it to a threat state, so that as our threat state changes, we are running a pre-designed segmentation and security policy, so that we can focus on the mission critical functions of those assets. So that was in the soul of our goals. The lack of subject matter experts, we believe that we can address this by really focusing on simplifying the problem. And one way to do that is just present the information in a unique visual manner and provide many different visual views for the same data set, so that it literally acts as a toolbox for that user. And the user type for us is a very wide array of user roles. So it's everything from an operator to a maintenance to a controls engineer, systems engineer, network analyst, all the way up to a CISO. That's a big nut to crack there. So what we want to do is we have some predefined visual roles, or layouts, if you will, but it's really about tuning it for an individual user and presenting that information in a unique way where they can see things very, very rapidly. So we're doing that on the networking side in terms of the flow, but also in terms of actually defining the policies. So looking at the first problem of solving the network visibility problem, what our approach here is to go into a learning mode so that we're capturing every node. So every MAC IP address, once we see that at the controller, we're capturing that. And then we're also looking at that node and any communication partner that is attempted from that node, capturing that. And then finally, we're looking at the actual conversation. So looking at detecting that protocol and then capturing that protocol. The goal here is to provide that complete visibility or situational awareness of what's on your network, who are they talking to, and what languages are they using.
Where is that insight being captured? At what zone do you, so if you're looking at it more holistically, then a lot of the communication that takes place, as you mentioned, is at that enclave level, at the level which devices exist.
Let's use this as an example here, right? So in our case, so first of all, we're pre-product stage. Our first release will be first quarter, and our MVP will be later in the fourth. What we did is we started, like a lot of switch vendors, to start with software. So we built our industrial virtual switch based on OVS as a means of experimenting and testing. And we did some protocol extensions right within the IDS. Now we've realized that there's actually another use case for this. There's a lot of virtualization that's happening today in industrial for runtime systems, SCADA servers, SCADA clients, and batch servers. So there's a need for a virtual switch in that infrastructure. But what we're doing right now is we're capturing the full packet stream at that low-level switch. So right now we've partnered with Schweitzer and utilizing their 2740S. And we're just now getting into some initial proof of concepts where we're capturing that. Right now, we're doing what every SDN vendor does. We've constructed a big simulation system of Mininet. But that's what we're doing, is we're capturing here. Now, our target is, if you think about this from a Purdue model, I would say it's between the basic control layer and one layer up, not necessarily going to the field device network layer. Again, it's going to be an answer that it depends. You know, if it's some types of Profinet requires like an MTech chip. If it's a protocol that can run on an everyday switch, we can target it. But we're not necessarily looking at the field devices today. Our contention, though, is that ultimately what you will do as an adversary is you will manipulate the behavior of the system. In order to manipulate the behavior of the system, you will do that via the thing that's controlling that behavior. So that's the PLC. So we think we're targeting the right area.
You don't see a need to kind of break the model that currently exists to start taking that data up to a higher level for other kinds of analysis?
Oh, no, absolutely. So I don't have a slide on our architecture, actually. So our architecture is actually split into two logical areas. So we're focusing on Docker and microservices. So within our controller, this is what we call our orchestration. We have a northbound API that is exposing our analytics framework. And this is where we're running all of our analytics, and this is actually where we're doing all the policy configuration. Our goal down the road is to open up an API, but to our analytics framework. But that's a whole other issue. But it's really about getting those switches in the right places. Another aspect that we're working on is, as we're in this learning mode, once we capture the 5-tuple and the basic metadata, now what we want to do is start characterizing those nodes and classifying the type as this is a PLC, this is an HMI, and again having that user. We're trying to make this more efficient by saving them time, but then they have to validate, yes, I agree, that's a PLC. And then finally what we're doing is I don't think I'll see this in my lifetime. What we really need is every vendor to create cryptographically signed hardware devices. That would be great. I will be retired before that happens.
I think one issue with bringing cryptography here is that the time for the control system to act is very short.
Yeah.
And I think this is an important reason why many of these vendors say that, oh, well, we can't use crypto because we can't get it done in time, if they haven't tried.
I agree. I have my own views on that. And actually, when I get into the zone slide, if I don't come back to your question, please remind me. And we'll have a dialogue there. But, yeah. So,
So there are a couple of uses of crypto, right? You're talking about encrypting the control signals.
yes. So
I think there's also, just signing the contents of those boxes, providing integrity.
Yeah, so I guess I didn't finish my thought, sorry, on the signature. So what our goal there is to have the best possible means of uniquely identifying a device. And if that device is a maintenance laptop that has the capability of moving throughout our network, we still have that identifier. And we're doing this with attributes and putting all these different attributes together and just generating a one-time hash. That's our approach today. We want to have a more robust approach, later. But
so we would probably use a term like a device fingerprint.
Yeah.
Signature, which might imply
fingerprint signature. Yeah.
graphic signature.
That's a good point. It's a good point. We want a GUID. So all this data that we're capturing, what we're doing is we're storing this for historical purposes. So we're really looking at having 3 different data stores, really an operational, historical, and then a long-term. The idea here is that once you deploy this type of a platform, that you can look back and perform analytics. And for example, you can actually do an x-axis little player and actually see different devices as they try to connect. Or there's some interesting visualizations you can do here. But it's also very important information that I can capture any device that's ever tried to touch the network, any conversation that ever tried to take place, and any protocol ever observed on that network. That's valuable information there.
So do you, sorry. Now I can see you have a full observability. Do you have control? I mean, from the SD controller, do you send open flow rules to the switch to allow and disallow?
Yes, that's exactly what we're doing. Yes.
Okay.
So right now, we're taking a basic building block approach. We're just kind of working on that 5-tuple thing. What we have successfully done within our IVS experiment, though, is so we're already doing the protocol identification, and we've got rules in place for CIP, Modbus TCP, DNP3, and I believe DNP3. I believe Goose was either just completed. See, there's 2 different aspects: our switch and then our simulation system. I'll talk about later. So that's been our focus right now, but that's really more of an experimental stage. What we're really doing, though, is identifying this at that controller in terms of the analytics. So even if during that learning mode, we can then know how we want to place that rule in terms of number of bytes that we're going to pad, or however we're going to do that within the rule.
But many of the vendors that I've seen, in my experience with Duke Energy, they have lots of heterogeneous way of putting encrypted tunnels. So you need the high-level gateways to establish these IPsec tunnels and for different things. So sometimes for authentication, sometimes for authentication and encryption. So SDN doesn't have this capability yet.
No, not yet. We're working on that. So we've actually have that integrated in our switch. So it's on-demand encryption and tone. The reason for that, but I'm getting ahead. When I get into the zones, my personal philosophy is when I have a zone is about trusted critical communications.
Yeah.
When I have trusted critical communications, I don't want to encrypt. Anytime I leave and I have a need for peer-to-peer communications across zones, now I have to consider that untrusted. Now I want to deploy encryption, but in a way, I'm going to go ahead and address your question.
Yeah.
But we're doing it in a way that does not impact the end device, because that end device could be a 20-year-old device. So I have to do this within that network fabric. So what we're doing it is within that switch infrastructure. So for example, from that ingress port of the source to the actual egress of the destination. So across that fabric, having that on demand. We're doing this in another way in terms of one of our other partners and investors, which is Microsemi. So they supply 3 of the top 5 industrial switch vendors with chipsets. So we started, our approach is we don't want to develop a switch. I could, but I've been in the space long enough to know I won't be successful. People won't buy from me, even if I have a better product, because they're going to buy from a Siemens because they're global presence and support. So I know enough that I won't do that. So how do I get the industrial switch vendors to do what I want? Create a platform that enables me. So I took the Trojan horse approach. I went earlier in the food chain to who's supplying the reference switches. And so I'm working on the reference switch with Microsemi and Vitesse, one of their acquisitions. And they have the MACsec. Now MACsec, to me, is very interesting to the industrial space because there's at least several protocols I'm aware of that are not at the IP layer, but at the transport layer. So MACsec can actually encrypt that payload at the transport layer. So, and that can happen right at the PHYs of the actual switch. So I think that's an interesting solution to the problem in terms of cross zones. So looking at solving the legacy mixed mode environmental problem. So this is actually a very real, I'm not just joking about NT4. There might even be some people in here that never even heard of it. You have to Google it. NT4, there's, for example, I won't mention the name, but there's a big air chemical supplier. They have 700 sites, and probably a good 50 to 60% is all NT. And it's a business decision. If it's not broke, don't fix it. You know, and they have a bottom line, so you know that's a challenge. So again, it goes back to that culture I was talking about, where in a larger system, they'll look at one line or one part of the system, and they'll do an upgrade and add some historian and some extended capabilities, and you know, running on a later OS. But now you've got a challenge of how do you, this is running on the same flat network in many cases. How do you secure this? So with what we're focusing on and what SDN enables is by focusing on that whitelisting, just focusing on what communication you want to allow. We're also working on really classification and prioritization of messages. So defining which protocols that we're going to prioritize, so that when we get into defining the shortest path or taking the most load balanced approach, we're doing this in a combination with the priority and classification as well as the security policy. So we're really focusing on a real tight marriage there between the two. So one of the key goals here is really identification of the communication behaviors. So at a system or network level, in our learning mode, we're really trying to identify the opcodes. And that's what we've done in our IVS today. So the actual operation codes or function codes of that industrial protocol that's saying, you know, read register or read registers or write register or, you know, read coils, that sort of thing. Or upload or download firmware. Because, and then we're trying to record this to create a profile of these actual assets. This way we can actually establish really a network baseline in terms of behavior of these machine-to-machine communications. For all the challenges we have in the space, this really should be a security expert's dream working in the space if they could do what they want, because you're talking about these communication characteristics that if you look at the runtime meter of most SCADA servers, you'll see that it probably only reboots maybe once every year and a half. I mean, think about that, right? So even if you have a dynamic protocol that's using dynamic port ranges, you look at the connection table, for all intents and purposes, it's static. So the communication partner I have today will be the same communication partner and pretty much the same profile 10 years from now. Wow, that's a great environment to be able to lock down. So we really have some advantages. So what our goal is we want to be able to identify what I call the runtime versus engineering or configuration. So the normal polling that takes place, you know, on a very cyclical basis between that PLC and these tag tables of a PLC, you know, this is going to be very, very, very similar over time. However, if I look at an engineering workstation that's actually downloading a new screen or an object to change to that HMI, that's going to be some different opcodes and function codes. So I'm doing the baselining in terms of the runtime system, but then once we go into an engineering phase or a change, that's when we're going into another phase of a learning mode just for that, so that we can really look at that delta and really get it down. So the engineering workstation, this should be more of a target and more of a focus in everything we discuss, in my opinion. The world is so focused on SCADA servers and PLCs, as they should, critical runtime. The golden goose is the engineering workstation. Because if I want to effectively change the behavior of your system, I have to learn that system. That's very, very difficult. But if I can get to the engineering workstation and just get that engineering data, that configuration, I know everything I need to know about your process. Now I can effectively craft an attack to do whatever I may want on that system. So what we're looking at doing is identifying those opcodes and function codes for any type of configuration-based change, and quite simply, dropping that. This feeds into one of our first applications, which we're calling the PLC change control. So that we have a mechanism to provide multi-factor authentication of a user, and then based upon their access, we'll expose what PLCs, for example, that they can make changes to. And doing this on their normal engineering workstation in a browser. So they're utilizing their same legacy tools for whatever PLCs they have. And then we'll allow those opcodes and function codes until that configuration job is done, and then we put those rules back to drop again. Now, this is not going to protect me from a sneaker net that manipulates the engineering data. But I've got full traceability of who made a change, from what device to what device, and when, and what was the description of the change. So from an IR standpoint, that still gives me a leg up. So it's an effective, easy solution. So some of the future experiments, and this is where data is going to be so critical, depending on the type of physical process. In a lot of the more discrete manufacturing-driven processes, we really anticipate to see a lot of time-based opcodes or function codes happening within a certain sequence of time. So when I see this, certain sequence of opcodes or function codes, I know that's going to be followed with a 90% of accuracy with these next ones. So that presents some really interesting opportunities in the future. So there's some areas where we can apply some machine learning once we get the data. It's hard to bring the data scientist with no data, though. So the same thing in terms of the sequences for continuous processes, but observation, at least down to the opcode and function code, even if you're not looking at the value within that payload, is highly valuable. So programmable segmentation in security zones or enclaves, this is really what drove us into this area to begin with. So one way that we're looking at this, and I really hesitate to use the word trust, but in a way it really is trust. What we're doing at a system level is observing those system communications so we can understand what are the machine-to-machine communications that are taking place very, very frequently, and we know they're highly dependent on one another. So that we can, let's not use the word trust, but let's call them logical process groups. So once I've identified these logical process groups and proposed this to the user of the system, they validate that. That might be my area where I say I need to establish trust because these are the critical machine-to-machines that need to communicate. And then part of our visibility aspect is when we do that classification of the device type, it's automatically assigned our Purdue layer model. So our version 1, we're just looking at that. In terms of subzones, we can automatically transpose that onto the visualizations. Customers can freely change that. Now, within that logical process group, this is where I want to be able to observe communications, but I will have a need for peer-to-peer communications between those. When I go between those, this is where we want to deploy encryption capabilities, and that is from that switch fabric. So from that egress physical port that's leaving this zone based on this particular profile to maybe this device over here to that ingress, that's where we're looking at applying encryption.
This is good. So I think I just want to mention something about SDN. So there are two ways to implement this. One way is to have the packet encrypted from the source all the way to the SDN controller to the app in the SDU controller. So you have to have an app there that takes care of this encryption, and then from the SDU controller back to the destination, which may be affordable if there's no real-time guarantees required. The other way is to build the middleware somewhere that takes care of this, because the SDN switches, as far as I know, it doesn't support this kind of capabilities. Maybe in the future, but they build this so it can be fast and simple. It doesn't have this complexity that can do encryption. So this is where I was asking the questions and how you're going to deal with this issue.
Yeah, so to answer your question directly, yes, I'm personally not aware of any SDN that supports it. But that's what we're doing with Schweitzer and Microsemi is, and part of this DOE project, is to actually define this next gen. So that's that, and quite frankly, what we really want to facilitate here is a world where all these switch vendors, they're still competing on their boxes, and it's about features and capabilities. So that when you're plugging in an SDN switch and it's announcing the features and capabilities, you understand what you can do in terms of security configuration, right? And how you would route based upon that, and how you'd recommend. So
there's some extra work,
yeah.
definitely.
But there's absolutely a need for encryption in terms of the switch to the controller. But what we're focusing on right now is how do we push down that configuration in such a way that we can facilitate this across zones. So that's really what our focus is there.
Roger, do you have any concerns as to what devices are on that or in that group? Is it at all like, enterprise environments where there are devices there you don't recognize or don't even know what their function necessarily is? Do you have the same kind of sort of things happening at ICS?
Yeah, today, yes. So one of the things that I deployed within our methodology at Siemens, doing the security assessments, was just kind of scrape, how many iOS and Android devices have plugged into that SCADA server. Now, was that really necessary? No, but it was effective psychologically, because you have this aspect where someone very innocently just needed to charge the phone, but that's a great transport mechanism. So yes, we are very concerned about this, but in our world, in this use case right here, for example, once we've identified this, we've proposed this, the customer's validating this of those devices, now we're locking it down. So to the point where if we have an unused port on that switch, someone plugging in their PC, it's a dead port because it's not even programmed. But the way we're covering our flanks, if you will, is if someone were to go over there and unplug that HMI and plug in their Kali Linux in a remote station, I fall back, I have that link down, link up event, and that signature. So I can really lock down that device to.
So I understand the need for integrity in these communications. Help me understand if you need confidentiality.
That's really dropped completely off the radar, I would say, for most of the industrial sector. If I had to classify it, I would say it's availability first and foremost, followed by integrity. Confidentiality.
So encryption here is serving the purpose of integrity.
Yeah.
A couple slides back, you mentioned gathering storage data over a period of time.
I'm sorry.
Are you doing any?
Here's a mic.
Storage
Data.
data. Couple slides back. Couple slides back, you talked about your storage data. Are you doing analytics on your storage data? You're looking for like patterns?
Absolutely. So truthfully, the way I need to answer that is I will. I'm not right now because in order to do that, I need the data. And to be honest, so we're a pre-product, so I'm working mostly on my simulation data, which gives me a pretty good a feel for the communication, but it's not the application context. But that's absolutely the goal. What we want is a foundational platform so that we're working with actually champions at some customer sites that believe in what we're doing and that will give us some access to that data, even if we have to embed an engineer at their facility, because it's all about the data. once we have that data, is just there's a wealth of analytics that we can perform that we're not even thinking about yet. The vision that I have here is that once we have this deployed and we're making progress, it's about recognizing a need and creating an app for that. Okay? Creating a need, creating an app, and it's just that's how we see this. So one thing I want to state here: so as we're defining these security zones, and then we're defining the whitelisting policy. So what communications I'm going to allow from this PLC to this ID, and maybe what I'm doing is just DNP3 there. So what I am doing is I start with a very base layer, and this is it's kind of cheesy, but customers kind of understand it, right? So at DEFCON 1, we're saying, okay, you have no threats, everything's just great. Maybe this is your most permissive. And then once you configure what you're going to allow, and maybe at that point it's just device to device level, not even getting into the specific protocols. Now, once I go at the next level of threat, now maybe I want to restrict it down to the protocol. Maybe the next level is what I'm actually doing is restricting which devices, because the goal here is to focus on the mission critical functions of these assets. So for example, you can't even buy a PLC today that doesn't have an integrated web server, an FTP server. And then a lot of the vendors, very stupidly, they enable them by default. And that's how you end up with all these Shodan searches, right? So is that mission critical? It sure as heck shouldn't be, right? I would go talk to your integrator if it is. But that's the idea, is to have a more and more restrictive policy that we're pre-designing and pre-testing, and then based upon that threat state changing, we're deploying that configuration. So that we're literally, we can change segmentation and zones and the policy based upon the threat level.
So how about NREC and Nestor recommendation? Nestor and NREC recommendations, kind of best practices that has been, is it considered in your?
Yeah, so I can explain the journey, if you will. So since I was early on, I was focusing on chemical and oil and gas. That's pretty much a non-regulated space, except for early CFATs for some chemical facilities. So within that sector globally, it's really about ISO 99 or the IEC 62443, right? It's probably the most accepted body of work. So that was really my first goal, was to, wow, if I could be the execution arm of ISO 99, that'd be great, because they've got a problem right now. They've got a really big standard, still in draft stage after 10 years, but it's a good family. So a customer gets it, okay, that makes sense. Oh wow, where do I start? So they actually have an execution problem. So what we really wanted to do is there a way that we could actually define, programmatically, security zones and conduits, and do this according to their SALs, their security assurance levels. So that was our initial journey. We pivoted away from that a little bit to just take a much more logical approach of, for our first release, let's give the user the full capability of defining whatever they want for a zone and subzones and policy. But as a starting point, let's focus on the logical process group. So if I'm monitoring the network communications of an entire facility, it's a chemical facility, for example, and maybe I've defined this logical process group 2, it's actually the loading area. This is dry goods and wet goods coming in on train, on rail, and by truck. And it's that entire system. And then maybe this is the cook-off area, unloading, that sort of thing. So looking at it from that logical process group of what devices are critical to run that particular process. I think it's a good place to start. That's my contention.
I think I agree. I completely agree. It would be so cool if the user or the system analyst, security analyst, can choose and opt in some of Nestor policies and see these networks compliance to this, or we want to enforce the configuration based on this segmentation that is being described by Enric or Nestor, because there are already a lot of work being done in how to segment the network, how to for ICS and control system. So if I want to not to start from scratch and just want to apply this kind of best practices, can I opt in? I mean, I'm just suggesting this.
So this is exactly where we want to go in time. You know, once post version 1, what we want to do is really focus on, you know, the SIP of really having that compliance piece. As a startup, though, I have to tell you, compliance just represents more R&D work for me to generate the mountains of reports instead of just the code that it takes to actually execute the security control.
You have no choice, right? You have to deal with compliance.
Exactly.
Critical assets, right?
So you know, that's the approach right now.
Maybe you can configure them from the beginning to be compliant.
Yeah.
Right. Or you check the compliance.
Yeah. But ideally, what we wanted to be able to do is be able to model virtually anything, whether it's an ISO 99, SIP, taking any standard body work. And now that we have that complete visibility, yeah, we should be able to model these. But that's going to come with time. But that's exactly where we want to go. And I think that's where the customers, it's about having that dashboard that in a one glance tells you, you're secure and this is why. Simple. So at this point, how am I doing on time? Ooh, I'll go really quick. So this is some extended, what I would think of as really foundational enablements in just a couple of use cases here. So, you know, one thing I look at here is looking at the cyber kill chain. You know, my read on this is most of the security controls, if you just walk the RSA floor, you know, they're really focused on this phase of that cyber kill chain. And, you know, depending on what report that you're subscribing to, you know, the adversary's been on your network for, you know, almost a year. Well, that's really scary to me in an industrial network. The idea that, you know, someone's on that network for so long. What we need is to change this paradigm around. Since we're looking at some of these legacy network services, such as ARP and things of that nature, DHCP, DNS, what we're doing is we're actually proxying these, which is decreasing that broadcast traffic. But it also gives us a unique capability now of detecting something like an ARP scan. Right? So with this ARP scan, now we got a unique opportunity, because now we can actually evoke some deception techniques. So we can send back some IP addresses that are actually not used. Maybe even randomize this, because when you're trying to map those networks as an adversary, as a red team, you know, if you're getting different pictures of that network each time, and then you're trying to fingerprint those OSs and you're getting false information back, it makes it very difficult, not impossible, but difficult to get in the weaponization stage. So this is really what one of our key focus areas is as well. We're really trying to identify right now what are some of the really needed IR support mechanisms. If we could erase the whiteboard of networking as we know it today, and we can really look at this from a fresh perspective, from a network hunter perspective, what are some tools that would be great for an IR? So this is kind of what we're looking at today. So what we're evoking is having that ability to have a request for filtering network stream of any asset and setting that up. So you've got the complete visibility, and they can simply select, they see something, some indicator, they want to capture some CIP traffic from that HMI, and maybe that's the source to destination being this PLC or something, and we send that up to the analyst. But also, I would say it's already the historical data that we're capturing in terms of configuration changes of the network. This is all extremely valuable information to help that IR teams be very, very effective, even in a remote capacity. So a little bit about our simulation system. So we started with, you know, like a lot of folks with Mininet. We built our industrial virtual switch based on an OVS. We did some customization there. We did some protocol extensions and then encryption. And then what we did is we took some Python simulators and we started with Modbus TCP, and then we were working with Rockwell originally, so we really focused on CIP. And now we've just completed DNP3, and we're working on Goose right now. So we can actually, in our simulation with Mininet, it's actually running our IVS, and we can spin up as many instances of that IVS. But we can also spin up as many instances of PLC and HMI communicating over legitimate sequences. So that's where we are today. What we're working on right now is to really make this a lot more generic. So it's almost like creating IXIA for industrial networks. So what we've successfully done now is we can take PCAP files and feed it into our app and basically parse this out, the message sequences, and store it within our data store. Still using our industrial virtual switch. Now what our goal, though, is to build a generic simulator that can actually feed in these sequences and that can simulate any type of an industrial device with any type of a message sequence. Of course, you're going to need a lot of PCAPs to kind of feed this, so it's only as good as the data you have. Once we've accomplished that, that's going to be really a great thing from a simulation perspective. But now, if we could start taking some malicious PCAPs, some known traffic, from a security vendor perspective, it's all about having access to data. So if you have a way to provide simulated systems with real-world sequences, but also some known malicious patterns, it's a great platform to study and learn from. Next, we want to take these different lessons from our experimentation, and once we get access to the data in some of these sectors, we really want to deploy some machine learning, because what we really want to do here is we want to understand that physical process, the cyber physical system, to an extent where we can literally simulate that system by leveraging components of our simulation. Maybe you're even plugging in some low interactive, high interactive honeypots in that as well. So that if you go back to that first use case of detecting an adversary trying to scan your network, instead of responding with deception, redirect them out of logical network into the sandbox that's simulating in an obfuscated way the actual process. And what occurs to me here is there's a tremendous wealth of TTPs we can extract from this. So last one. Where we really want to go is we want to bring the ecosystem together. We want to bring the security community together via a northbound API to address this problem. We feel like we have a better way to supply better data versus the span approach today. Now, that's our goal. We want to open this up for large customers to write their own apps. The challenge here, though, is how do we ensure the integrity of those applications that are connecting into our platform? How do we establish that trust and ensure that trust? We don't have answers to that yet, and that's why we're not exposing it yet. When I look at some of the SDN space into the other markets right now, I see it moving very rapidly, but not necessarily what I would call responsibly. And it kind of scares me, because it is the keys to the kingdom. With all the benefits of SDN, there's some scary things here. I can secure the flanks and the rear, and I can focus my attention on that management interface, but that management interface is where I'm really concerned right now. Just a little bit about it. So I'm not the SDN expert. I can talk about it pretty well at this point. So Pankaj Berdi, I recruited him. He's our Chief Development Officer. He's one of the founders of Onos. I found him as I was looking for the best open source platform to build on top of. And Paul Meyer, he's our CEO, been around the enterprise space, security space a long time. Some of you might know Bob Hoover. He's been awesome. Eric Kosman's vice chair of ISO 99. So we're really looking at working with ISO 99 to do some remodeling. So that's who we are. One shameless plug, I'm recruiting, so if any of your students are looking for a new home, please give me a call. Love to talk to them. Even, intern on interesting projects or some permanent placement homes. With that, I'm done. Thank you for your time. Yes.
It was a really nice presentation. I have a question regarding real-time and performance constraints. In some cases, some of the things I saw in your pictures have real-time requirements for communication. Are those requirements easy to meet with your current configuration? Is something you just don't really have to worry about, or you have to worry about that as well? I'm thinking specifically, just to give an example, with Schweitzer, they use mirrored bits, right? Mirrored bits, they believe is important to give them some deterministic timing. And I wonder if any of those kind of issues come up with you.
So they are, but full disclosure, right now, all of our testing has been in the simulation arena. So where it really becomes much more apparent is when we're building out in the Schweitzer lab now. So yes, I am very concerned about a lot of those, but most of that concern and the feedback we've gotten also is about that initial configuration. Those packets when you're first deploying, going to the switch, I don't know what to do with it. I've got to go to that controller, send down a rule of how to process it. So I know Schweitzer's looking at a very proactive model where they want to apply it in the same way that you engineer a lot of electricity flows, so that they're actually engineering those flows up front, for the primary path and maybe like a backup path. We're looking at a slightly different perspective. I think we're getting caught in an argument here, in my opinion. If you look at a control system when it was very first commissioned, right? What happened at that very first switch as it was doing its own learning mode to build up its MAC tables, right? It had to broadcast out every port and wait for a response so it can build up its table. So what I'm really anxious to do is get to the point where I can actually look at some hard data of what is the difference from an initial traditional industrial switch doing that learning mode, and because I know that can take some time, versus SDN. So one of my concerns is more on the configuration side, because once the rules are in place, I really don't anticipate any.
Do you know what the timing requirements will be? So the vendors you're working with, have they told you, and are you designing to timing requirements?
Yeah, so we're actually just working through this process right now with Schweitzer. So we should have their switch, and then we don't actually have their switch yet. It should be coming in the next couple of weeks. And we just visited Pullman. We should be getting into their lab here in the next 3 weeks or so. So we're kind of going through all of these requirements right now. So one of the things that came out of their field testing of their SDN switch, though, was really focusing on the resiliency. So they showed, for example, demonstrated 100 microsecond link recovery time, which blows away any of the current industrial redundant communication. So the way they're approaching their validations with their customers is really from a traditional, network resiliency, speed, and performance. So we're just kind of merging our two worlds together. And knock on wood, hopefully in 2 weeks we'll be funded by Schweitzer. So we got a good partnership going with these guys. They're great people to work with. So we're still working on these requirements now.
And what's the timeline of getting the product?
So right now so in the startup world, everything's about MVP, minimal viable product. I have a slightly different definition of this for the industrial space, because my concern is the industrial, guys are going to, what do you mean minimum viable product? To me, that's a field testing, field ready deployment within a lab. That target for me is in the fourth quarter. My version 1 release will be in the last part of the first quarter, 2017. So that's our first, and we've partnered with Ameren and Sempra on the DOE, and fully anticipate them to be some of our first, customers and deployments.
Well, thank you very much.
Thank you.